Hi everyone, welcome to this new video over network segmentation. In the first point is broadcast domain and segmentation. Have you ever received an email that was addressed to every person at your work or school? This was a broadcast email. Hopeful, it contained information that each of you need to know, but often a broadcast is not really pertinent to everyone in the email list. Sometimes only a segment of the population needs to read that information. In an Ethernet LAN device use broadcast and the address resolution protocol ARP to locate other devices. ARP sends layer 2 broadcast to node IPv4 address on the local network to discover the associated MAC address. Is media access control. Devices on Ethernet LANs also locate other devices using service. A host typically acquires its IPv4 address configuration using the Dynamic Host Configuration Protocol (DHCP), which sends broadcasts on the local network to locate a DHCP server. Switches propagate broadcasts out all interfaces except the interface on which it was received. For example, if a switch in the figure were to receive a broadcast, it would forward it to the other switches and the other users connected in the network. Eh, I refresh this page. Wait a minute. Wait a second, sorry. Okay. I repeat, switch propagate broadcasts out all interfaces except in the interface on which it was received. For example, if a switch in the figure were to receive a broadcast, it would forward it to the other switch and other users connect in the network. In this case, is connect to router 1 and the router 1 is connect to the internet. And broadcast domain is the switch, the switch, the switch, and the switch. Okay, this is a router segmentation broadcast domain. Routers do not propagate broadcast. When a router receives a broadcast, it does not forward it out other interfaces. For instance, when router 1 receives a broadcast on its Gigabit Ethernet 0/0 interface, it does not forward out another interface. Therefore, each router interface connects to a broadcast domain, and broadcasts are only propagated with the specific broadcast domain. The next point is problem with large broadcast domain. A large broadcast domain is a network that connects many hosts. A problem with a large broadcast domain is that this host can generate excessive broadcasts and negatively affect the network. In the figure, LAN 1 connects 400 users that could generate an excess amount of broadcast traffic. This results in a slow network operation due to the significant amount of traffic it can cause, and a slow device operation because a device must accept and process each broadcast packet. This is very important. Okay, this results in a slow network operation due to the significant amount of traffic it can cause and a slow device operation, because a device must accept and process each broadcast packet. A large broadcast domain. Okay, this is the same example. Internet connect to the router 1 in the port Gigabit 0/G or Gigabit 0/0 connect to the switch, and the switch is connected to 3 switch. And this is the LAN 1 with this IP address 172.16.0.0/16, with 400 users. The solution is to reduce the size of the network to create the smaller broadcast domains in a process called subnetting. These smaller network spaces are called subnets. In the figure, the 400 users in LAN 1 with network address 172.16.0.0/16 have been divided into subnets of 200 users each. In the first is 172.16.0.0/24 and 172.16.1.0/24. Broadcasts are only propagated within the smaller broadcast domain. Therefore, a broadcast in LAN 1 will not propagate to LAN 2, communicating between networks. Okay, in this case, to the internet is connected to the router, and the router is connected in the port gigabyte 0/0 and the port gigabyte 0/1. This is one la- this is one LAN and this is the other LAN with 200 users and 200 users. Notice how the prefix length has changed from a single /16 network to /24 network. This is the basis of subnetting, using host bytes to create additional subnets. Note: the terms subnet and network are often used interchangeably. Most networks are subnet of some large address block. The next point is reasons for segmentation network. Subnetting reduces overall network traffic and improves network performance. It also enables an administrator to implement security policies such as which subnets are allowed or not allowed to communicate together. Another reason is that it reduces the number of devices affected by abnormal broadcast traffic due to misconfiguration, hardware software problems, or malicious intent. There are various ways of using subnets to help manage network devices. And we have three tabs. In the first tab is location, subnetting by location. In this case, we have a building with 5 switch, and in each switch have one IP address. In this case, is LAN 5 in the fifth floor. In this case, this is the IP address for the LAN 4 in the fourth floor. And this is the LAN 3, LAN 2, and the LAN 1. All this LAN is connected to the router 1. The next tab is group or functions. Group or functions, subnetting by group or functions. In this case, the router is attached or connected to four routers. In the first case is in the port gigabyte 0/0 for the administration with the LAN 1 with this IP address. In the next is gigabyte 0/0 connect to the students LAN 2. The next is gigabyte 0/2 connect to the according. In the last is connect to the port gigabyte 0/3 human resource with this IP address. And the last is device type, subnetting by device type. In this case, the router is connected to three switches. In the first port is gigabyte 0/0 with this LAN. In the next is LAN 2 with connect to the port gigabyte 0/1. In the last is this IP address attached to gigabyte 0/2 port. Network administrators can create subnets using any other divisions that make sense for the network. Notice in each figure, the subnets use long prefix lengths to identify networks. Understanding how to subnet network is a fundamental skill that all networks administrators must develop. Various methods have been created to help understand this process, although a little over mean and first pay close attention to the detail and with practice of netting will become easier. Finish with a quiz. In the first question is which device will not forward an IPv4 broadcast packet by default? This is which device will not forward an IPv4 broadcast packet by default? This is a router. That's right. Routers will not forward an IPv4 broadcast packet by default. The next is question 2. Which two situations are the result of excessive traffic broadcast? This is a slow network operation and a slow device operation. That's right. Slow network operation and slow device operation are the results of excessive broadcast traffic. And finish with IPv4 and network segmentation summary. What did I learn in this module? In the first tab is IPv4 unicast, broadcast, and multicast. Unicast transmission refers to one device sending a message to one other device in one-to-one communication. A unicast packet has a destination IP address that is a unicast address which goes to a single recipient. A source IP address can only be a unicast address because the packet can only originate from a single source. This is regardless for whether the destination IP address is a unicast, broadcast, or multicast. IPv4 unicast host addresses are in the addressing range of 1.1.1.1 to this address. In the next is broadcast transmission. This refers to the device sending a message to all devices on a network in one-to-all communications. A broadcast packet has a destination IP address with all ones in the host portion, or 32 bits. A broadcast packet must be processed by all devices in the same broadcast domain. A broadcast might be direct or limited. A direct broadcast is sent to all hosts on a specific network. A limited broadcast is sent to this address by default. Routers do not forward broadcasts. And the last is multicast transmission. Reduce traffic by allowing a host to send a single packet to a selected set of hosts that subscribe to a multicast group. A multicast packet is a packet with a destination IP address that is a multicast address. IPv4 has received this address to this address as a multicast range. Each multicast group is represented by a single IPv4 multicast destination address. When an IPv4 host subscribes to multicast group, the host processes packets addressed to this multicast address and packets addresses to its uniquely allocated unicast address. The next tab is types of IPv4 addresses. Public IPv4 addresses are addresses which are globally routed between ISP routers. However, not all available IPv4 addresses can be used on the Internet. There are blocks of addresses called private addresses that are used by most organizations to assign IPv4 addresses to internal hosts. Most internal networks, from large enterprise to home networks, use private IPv4 addresses for addressing all internal devices, intranet, including hosts and routers. However, private addresses are not globally routable. Before the ISP can forward this packet, it must translate the source IPv4 address, which is a private address, to a public IPv4 address using NAT. I don't remember what is NAT. Is address translate, but I don't know what is N. Uh, so loopback address are more commonly identified as 127.0.0.1. These are a special address used by a host to direct traffic to itself. Linked local address is this. are more commonly known as the automatic private IP address or self-assigned addresses. They are used by a Windows DHCP client to self-configure in the event that there are no DHCP servers available. In 81, IPv4 addresses were assigned using classful addressing as defined in Request for Comments RFC 719 assigned numbers. Customers were allocated a network address based on one of three classes, A, B, or C. The RFC divides the Unicast range into a specific class of followers. In the first is class A or Class A, designed to support extremely large network with more than 16 million host addresses. The next is Class B, designed to support the needs to demonstrate to the large-size network with of the approximately 65,000 host addresses. In the Class C, this class is designed to support the small networks with a maximum of 254 hosts. There is also a Class D multicast block consisting and a Class A experimental address block consisting in this range of address. And public IPv4 address are addresses which are global routed over the internet. Public IPv4 address must be unique. Both IPv4 and IPv6 address are managed by the IANA. The IANA manages all allocated block of IP addresses to their rears. Rears are responsible for allocating IP addresses to ISP who provide IPv4 address blocks to organizations and smaller ISP organizations can also their addresses directly from rear. In the last tab is in an Ethernet LAN device use broadcast and ARP address resolution protocol to locate other devices. ARP sends layer 2 broadcast to node's IPv4 address on the local network to discover the associated MAC address. Media access control. Devices on Ethernet LAN also locate other devices using service. A host typically acquires its IPv4 address configuration using the HCP, which send broadcasts on the local network to locate the HCP server. Switches propagate broadcasts out all interfaces except in the interface on which it was received. A large broadcast domain is a network that connects many hosts. A problem with a large broadcast domain is that this host can generate excessive broadcasts and negatively affect the network. The solution is to reduce the size of the network to create a smaller broadcast domain in the process called subnetting. These smaller network spaces are called subnets. The basic of subnetting is to use host bytes to create additional subnet. Subnet reduces overall network traffic and improves network performance. It helps administrators to implement security policies such as which subnets are allowed or not allowed to communication together. It reduces the number of devices affected by abnormal communicate broadcast traffic due to misconfiguration, hardware problems, hardware software problems, or malicious intent. And Webster reflection question. I just sent invitation to a party to several of my friends and family. The invitation went to different addresses, but the card inside is the same for everyone. This is like a multicast email, isn't it? I didn't know you could do that. I also didn't know you could send a broadcast email to every person on your network. Can you think of a good reason to send a broadcast email to everyone in your network? Can you think of a reason why you should be careful before you send a broadcast email? Finish with IPv4 and networking segmentation. The first is question 1. Which statement describes one purpose of the subnet mask settings for a host? It's used to describe the type of subnet? No. It's used to identify the default gateway? No. It's used to determine the which network the host is connected? Yes. Question 2. What is one reason for subnetting an IPv4? to reduce the scope of broadcast flooding, to increase the number of available host address on the network node, to remove the need for network service that rely on broadcast via ICP, ensure that all devices can communicate with each other without requiring a router to reduce the scope of broadcast flooding. The next is a message is sent to all hosts on the remote network, which type of this is multicast. Question 4. A user is unable to access the company server from a computer. On using the ipconfig command, the user thinks that the IP address of the computer is displayed. Okay. What type of address is this? Is private. I don't know. I don't know what is. I say it's private. Yeah, it's private. Question 5. Which three IP addresses are private? Okay, is this, and this. Yeah. Question 6. Match each description with an appropriate IP address. Okay. This is public. A loopback. I think this is. Question 7. Which network device can serve as boundary to divide a layer to broadcast domain? Which network device can serve a boundary to divide a layer to broadcast? Access point, Ethernet hub, Ethernet bridge, router. Which network device can serve as a... I need to translate this part. So a router. What is the role of IANA? Maintaining standards related to electrical wiring and connectors, documenting develops or new protocols, managing the allocation, promoting the development evolution. Okay. Question 9. Which of address prefix range is reserved for IPv4 multicast? Okay. I think is this. No, is this. Question 10. A high school in New York, School A, is using video conferencing technology to establish student interaction with another high school, School B in Russia. The video conferencing is conducted between two end devices through the Internet. The network administrator of School A configures these end devices with the IP address. The administrator sends a request for the IP address for the end devices in the school B, and the response in this. Okay. Neither school is using a VPN. The administrator knows immediately that this IP will not work. Why? This is a loopback address. This is a link local address. This is a private. There is an. This is a private. Question 11. A host is transmitting broadcast which other host will receive. All hosts in the same network. All hosts in define a group of hosts. The closest neighbor. All hosts on the internet. Okay. Oh. Okay. Remember that you can return. Okay. This is bad. A specially defined group of hosts. Okay. This is a private address. Okay. Okay. Router. And experimental. Public. Okay. 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 I review assessments. Okay. Reset and go to the question 1. Which statement is describe one purpose of the subnet mask setting for a host? This is no, it's used to determine at which network the host is connected. Okay. A message is sent to a host on a remote network. What type of message is it? Limited broadcast, directed broadcast, limited or direct broadcast. Question 4. A user is unable to access the company. This is private. Which okay is this? No, this no. Okay, this is a public. Sorry, this is a public. Uh, experimental. Okay. Which network device can serve a boundary and documenting, managing the allocate. I don't remember what is the role of Yana. Okay. And a host is transmitting a broadcast. Which host or host will receive it? Okay. Mhm. Okay. Okay. Reset again. Okay. It's used to describe. Okay. Okay. Is loopback or link local? Okay. Link local. Okay, which three IP addresses? Okay, 127 is look back. Okay, this is here and this is here. This is a router. Managing the allocation of IP addresses and domain names. Okay. Okay. And this is a private. Okay. Well, this is all for this. See you in the next one. Bye.